24. We need to find the value of P and Q. In this case, for this quadratic, we need to use completing the square method. So the equation we've got is 4x minus 5 minus x squared. And we need to write that in the form of ax squared plus bx plus c. And that would be minus x squared plus 4x minus 5. You can see from there that a equals minus 1, b equals 4, and c equals minus 5. To do completing the square, using ax plus bx, I need to divide everything by a in the first two terms, not in the, I need to take a out in the first two terms. So that's what I'm going to do. I'm going to make the coefficient of a here be 1. Right now the coefficient is minus 1. So I'm going to rewrite this and write equals, I take minus 1 out using the square bracket, get x squared minus 4x minus 5. All I did was divide the first two times by minus 1, or take minus 1 out. Now the coefficient of x squared is 1. And because coefficient of x squared is 1, I can now apply completing the square, and this is what I'm doing. If I have x squared plus bx, applying completing the square will be x plus b squared over 2, x plus b over 2 squared minus b over 2 squared. So that's completing the square. So that's what I'm going to apply to here. So I've got my minus 1 that will come along. My x will become x. My sign will be minus because it's minus there, so it comes down. The 4 will be divided by 2, that's b over 2. So that'll be 2, open and close, square it. So take away the square of b over 2, which is 4 over 2, which is 2 squared, which is 4. Close the square bracket, and that's completing the square done on the first two terms. And then bring down the minus 5. And that's how we do completing the square. Now I need to open the square bracket, which implies that I need to open the square bracket, and I get minus x minus 2 squared plus 4, because minus 1 times minus 4 is plus 4, and then minus 5. And that will give minus x minus 2 squared minus 1. The minus 1 is the value of y at the intercept on the turning point, and I have to set the x to 0. The x minus 2 in the bracket here will be set to 0, and therefore x will be equal to 2. At the turning point TP, the coordinates will be 2 and minus 1. So that's what completing the square tells us, the turning point coordinate. So now the value of P from the question, so we go back to question here, we need to find the value of P and Q. So I can write my answer as x minus 2 minus squared minus 1 can be written as minus 1 minus x minus 2 squared, where q, that's q plus the question plus p squared. You can see that my q equals -1 and p equals -2, and this one is minus. Question B asks for discriminant. D is a discriminant, which is b squared minus 4ac. We know the value of b. B is 4, a equals -1, and c is -5. So if I substitute those values in here, I'll get 4 squared minus 4 into bracket minus 1 into bracket minus 5. If I multiply out, that'll be 16 minus 4 times 5 is 20, plus 20 minus 20. So that's 20 minus. And that will be -4. Because D is less than 0, the quadratic will have no real roots. So that means the roots is complex root. For C part, we need to sketch the curve. So sketching the curve, I draw my lines. That's my y-axis. And this will be my x-axis. Y-axis, the equation of y-axis is x equals to 0. This is x-axis. The equation of x-axis is y equal to 0. Now, we know the turning point. At the turning point, x is 2, y is -1. And the intercept on the graph is y is -5 at x equals to 0. So if I have the graph as -1 here, -2, -3, -4, -5, 1, 2, 3, 4. When x is 2, y is -1. That's the turning point. And at the intercept is -5. So to sketch the curve, we've got a turning point here, and coming all the way from the turning point through to -5. So the curve is maximum, and the coordinates we're going to have will be at the intercept on the y-axis, because 0 coordinates and -5. And the turning point here has a coordinate of 2 and -1. And the equation for this graph is y equals -x squared plus 4x minus 5. So this is intercept on the y-axis. And this is the maximum, and then a turning point. Sometimes people call it a vertex.